Good afternoon, everyone. Today we will discuss how to distinguish aldehydes from ketones. So there are particular tests which are performed to distinguish aldehydes and ketone, and one of them is oxidation reactions. How oxidation reactions will help to distinguish these. So moving ahead to discuss it in detail. Yeah. So Oxidation of aldehydes. Oxidation of aldehyde is achieved very easily as compared to ketones because in aldehydes there is a bond between carbon and hydrogen, which is easy to break. But in case of aldehyde, there is bond between carbon and carbon, which is not easy to break. In this case of aldehyde, this hydrogen can be shifted toward oxygen. That's why aldehydes can give oxidation reaction easily to form carboxylic acids. Clear? So this is the first method. So by which reagent, by using what kind of reagent we will do oxidation reaction of aldehyde so that we can distinguish it from ketones, because ketones can also undergo oxidation reaction, but under only strong oxidizing agents. But aldehydes can also undergo oxidizing reagent under mild reagent also. So there are several reagents such as nitric acid, potassium permanganate, potassium dichromate. These are the strong oxidizing agents. These oxidizes both aldehydes and ketones. But there are some several weak oxidizing agents such as bromine water, silver ions, and copper ions. These oxidize only aldehydes because these are weak in nature. These are mild, as aldehyde is more reactive to ketone. That's why aldehyde give these test positive. So we will use these reagents to oxidize aldehydes if we have to distinguish aldehydes and ketones. Suppose you have two test tubes and one of them is aldehyde. In first one is there is aldehyde group, and in second one the group present is ketone. So if your supervisor asked you how to distinguish these two, then you will perform the two tests. One is tollens reagent test, another one is fehling solution test. So aldehyde will give these two tests, positive test, but ketone will never react with these reagents. So by this you can figure out that in the first test tube there is aldehyde and in second test tube it is ketone. Then how tolerance reagent is reacting with aldehyde and what is the formula of tolerance reagent? And look at this reagent. Yeah, this is your tolerance reagent. Basically, tolerance reagent, it is an ammonical solution of silver nitrate. And how tolerance reagent is prepared? It is prepared by adding ammonium hydroxide to silver nitrate. Once the ammonium hydroxide is added to silver nitrate, there is formation of precipitates of silver oxide, which is gray in color. Once these precipitates are formed, again, these precipitates redissolve. Upon redissolving, it forms tollens reagent. Yeah. So this complex is silver and two molecules of ammonia, and the outer ligand is hydroxide. So this is known as tollens reagent. So how it reacts with aldehyde? So this is aldehyde. R group may be any aliphatic group, CH3, either any aromatic group. It may be phenyl ring also, such as benzaldehyde, acetaldehyde, CH3COH. You can take any kind of aldehyde, but that should be saturated and aromatic aldehyde. When it is subjected to react with tollens reagent in the presence of mild base. So basically, tollens reagent is mildly basic in nature as it has hydroxide group also. The presence of hydroxide group makes it basics, but mildly basics. Okay, and it is heated in the presence of Tollens reagent is heated in the presence of aldehyde. It led to formation of carboxylate ions with the formation of silver precipitates. So these silver precipitates once formed, these get deposited upon the side walls of the test tubes and shines like a mirror. So that's why this test is also known as silver mirror test. Yeah. So this is the only indication to distinguish aldehyde if silver get deposited on the walls of test tube and it shines like mirror. So you can distinguish aldehydes from ketone once the silver is formed. Silver mirror is formed. Clear? Okay. Then so both aliphatic and aromatic aldehydes reduce tolerance reagent. You can also say this in another terms, these reduce tolerance reagent. As in this case, the oxygen is inserted here. This aldehyde is oxidized to carboxylic acid. Yeah. So itself aldehyde is oxidized. If aldehyde is oxidized by some reagent, then it means it is reducing some other reagent. So aldehyde is oxidized and silver is reduced, as here the silver has oxidation state of +1, but when you look at this simple silver, when there is no charge on silver, then it has oxidation state of 0. So from the oxidation state of silver is moving from +1 to 0. So there is a gain of electron. When the silver positive will gain 1 electron, it will convert it into Ag. So silver is undergoing reduction and this aldehyde is undergoing oxidation. So both oxidation and reduction are occurring simultaneously. So in other terms, we can also say aliphatic and aromatic aldehydes reduce tolerance reagent. Clear? So my question is why only aliphatic and aromatic aldehydes are reduced, not ketone? So I have told you clearly ketone cannot be reduced by tolerance reagent because this is mild oxidizing agent. It's very difficult to break this bond. So this is the reason. To clarify more about aliphatic and aromatic aldehydes, why only these aldehydes, we will look at the mechanism and study it in detail. So moving towards the mechanism, how Tollens reagent oxidizes aldehydes. In this case, the two molecules of Tollens reagent and three of hydroxides we are using and two molecules of water are formed as byproduct. So this is the mechanism. Yeah. The first one is your aldehyde group. Okay, so this pi bond can be represented as like this bond, this intermediate, and the carbon carrying positive charge and the oxygen carrying negative charge, because these pi electrons can be shifted towards oxygen. As oxygen is more electronegative as compared to carbon, then the carbon will occupy the positive charge and the oxygen will get the negative charge. Further, when it is subjected to react with the Tollens reagent, so first of all, what happens? This oxygen will transfer its electron to the silver positive. Then the one molecule of silver positive gets reduced to Ag, Ag positive to Az. Now, this oxygen has lost its one electron. Now it become neutral. It carries one electron. So this is oxygen radical because it carries only one electron. And the carbons like intermediate 2 again carries positive charge. There is no change in the positive charge of the carbon as intermediate 2 and 3. Okay, the next is attack by hydroxide ion. Now, this carbon is electrophilic center because it carries positive charge. It is electron deficient in nature, so nucleophile can attack it on very easily. Now, OH negative is attacking on this carbon positive. What happens? These two charges get neutralized and the bond between carbon and oxygen is formed. This is your fourth intermediate. In next step, there is shift of hydrogen atom. It will get shifted towards this oxygen. The oxygen carrying one electron and this one electron from hydrogen. It will form bond with each other, thus forming OH group, and the carbon will left with only its one electron. Now here the carbon have a one electron, so there is a carbon radical here. But in intermediate 3 there is one electron occupied by the oxygen. But in the intermediate 5 the carbon carries free radical. Again, the second molecule of silver positive will react with this carbon free radical and the carbon will give its electron to silver positive. Upon losing its electron, the carbon will get the positive charge. Okay. So this is your intermediate number 6. In next step, again, then you can say we have used two molecules of silver positive until the step 6 intermediate and one one molecule of hydroxide ion. Now the second molecule of hydroxide ion is reacting with intermediate 6. It will abstract the proton from this intermediate and the oxygen will acquire negative charge. So this is in and form the intermediate 7. Okay. Okay. Again, intermediate 7 will get protonate. The intermediate 7 will form the intermediate 8. How these electron will back shifted to carbon because the carbon has positive charge and oxygen has negative charge. There is formation of a double bond between carbon and oxygen, this forming carboxylic acid. Now, third hydroxide ion is reacting. It is forming carboxylate ion with the formation of a water molecule. Again, this carboxylate ion carrying O negative charge, it can abstract proton from water molecule which is H3O positive. Upon abstraction of proton, it form again carboxylic acid and forming again one molecule of water also. So in the whole mechanism, two molecules of silver positive are used and three molecules of hydroxide are used. And there is formation of two molecule of water also. So this whole explains how the carboxylic acid is formed. This step is very important in which there is formation of intermediate 4 and the intermediate 4 undergoes hydrogen shift to form the carbon free radical. So this mechanism derives the oxidation of aldehydes. That's why ketones are not oxidized using tollens reagent. This is the one of the major reason because ketones do not have carbon hydrogen bond also. So this is all about the mechanism. So from it is very clear that only the aldehydes can be oxidized using tollens reagent. But there is also a one exception. What is that exception? So the first structure is the structure of glucose and Look at the second structure. This is a structure of fructose. Clear? In glucose, there is aldehyde group at first position, and in case of fructose, there is presence of ketone group. As I have clearly told to you guys, the fructose have ketone group. Okay. Fructose can also be reduced using tollens reagent. It's very wonderful. Now you guys will say, you are saying the ketones cannot be reduced by tollens reagents. So it's only the fructose. If we are talking about sugar molecules, out of those, only fructose can be reduced by tollens reagents, which involves ketone functional group. Why only fructose can be reduced? Because of there is formation of tautomerization. So this is your fructose molecule. Consider it this part R. So I have made this structure 1, sorry, structure 2, and it's A. The first is CH2 group, the second is carbonyl group, and the third is COH group, and this whole group I have represented it with R group. R group. Okay. So here is the CH2. Here. Okay. This is your keto form, but it again undergo tautomerization that is called ketoenol. This is your keto form and this is your enol form. Enol. The carbon carrying two hydrogens, one of the hydrogen get transferred to this oxygen, and this pi bond get converted into single bond, and there is formation of a bond, double bond between carbon and carbon. So that's why due to tautomerization, this can be oxidized using tollens reagent. Clear? So if I would like to summarize, in summary, you can say using tollens reagents only aliphatic and aromatic aldehydes can be reduced along with fructose. Fructose is the only ketone which can be reduced using tollens reagent. So I have already explained the reason to you guys why it is oxidized. Clear? So tollens reagent is reduced and aldehydes and ketones are oxidized, and the ketone which is fructose, only this ketone is oxidized. Okay, then the second one is fehling solution. Okay, it is very clear from the starting, only tolerant reagents and fehling solution distinguish aldehydes and ketones. The fehling solution has one more peculiar property. It also distinguishes aliphatic aldehyde from aromatic aldehyde. So this is a particular property of fehling solution. So it can also distinguishes both. So fehling solution is reduced only by aliphatic aldehydes. It is positive for aliphatic aldehydes which are saturated in nature. So this give positive test. But aromatic aldehyde do not give fehling solution test. Clear? So this is about the fehling solution. Now, what is fehling solution? So you must know the fehling solution. What are the components of fehling solution? It is comprised of two components. One is fehling solution A, another is fehling solution B. And first of all, what is fehling solution A? It is a copper sulfate solution. Clear? And fehling solution B, it is the alkaline solution of Rochelle salt. Alkaline solution means it is made in alkali such as sodium hydroxide, which is very strong. Here the alkali medium is very strong. Yeah. And what is Rochelle salt? This is the structure of your Rochelle salt. It is also known as sodium potassium tartrate. Tartrate. Clear? So this is the structure of your Rochelle salt. Okay. When these both two, pheling A and pheling B, are mixed, these form pheling solution, which is deep blue in color. So first is when copper sulfate is reacting with sodium hydroxide, when these two are mixed, what is happening? As pheling B contains sodium hydroxide as well as Rochelle salt. Okay. When this solution is mixed with pheling A solution, the copper sulfate will react with sodium hydroxide. It will form copper hydroxide. Yeah. So this sulfate is replaced by these hydroxide groups. Here, both the molecules have the oxidation state of +2. Now, this cupric hydroxide will react with Rochelle salt. Upon reaction with Rochelle salt, there is removal of two molecules of water. When molecule of water is removed, this will form the complex with the remaining part of this tartrate group, as this O is linked with carbon. Sorry, from here the water is removed, H2O. OH from tartrate group and H from cupric hydroxide group. By this, two molecules of water are removed. Okay. And this oxygen will get form the bond with this carbon and the second carbon of tartrate group. So this is basically a complex. This complex have deep blue color. Okay. So this is your fehling solution. When fehling solution is subjected to react with saturated aldehyde, it gives carboxylate ion. Again, this is oxidized into carboxylic acid along with the formation of cupric oxide, which gives red precipitate with three molecule of water. The formation of these red precipitate is a positive indication for the presence of aliphatic aldehyde. So if the red precipitates are formed during this reaction, it means the aliphatic aldehyde is present in the test tube. So look at the test tube number 1. It contains aliphatic aldehyde when it is reacted with fehling solution, as fehling solution is blue in color. Okay. Then upon reaction after some time, it turns into red. Red color is due to formation of precipitates of cupric oxide. So this is the reason why ketone do not give test with fehling solution also, due to lack of the carbon hydrogen bond. And the next one I told to you, aromatic aldehyde do not reduce fehling solution. Why? If we look at the structure of aliphatic aldehyde and aromatic aldehyde. So in case of aliphatic aldehyde, phenyl is electron withdrawing group. Okay. So due to this, it will pull the electrons from this carbonyl group. It makes less reactive as compared to saturated aldehyde group due to its electron withdrawing effect of phenyl group. Okay. So as well, this benzaldehyde group will give side reactions. Why? Side reactions, it do not have any alpha hydrogen. Okay. So Fehling solution is highly basic in nature as compared to tollens reagent. You guys will ask, tollens reagent gives oxidation of benzaldehyde, but not Fehling solution do not give the oxidation of benzaldehyde because of the difference between two solution. The tollens reagent is less basic in nature, but the Fehling solution is more basic in nature, that is highly alkali. When it is subjected to react with Fehling solution, it gives side reactions such as Cannizzaro reaction. In Cannizzaro reaction, there is the aldehyde group do not must have alpha hydrogen. So it do not undergo reaction with Fehling solution. This is also the one of the major reason due to the sensitivity of both reagents. The Fehling solution is highly basic in nature as compared to tollens reagent. Clear? So the another one is aromatic aldehydes are less reactive under basic conditions also, because these aromatic aldehyde, the phenyl ring stabilizes this carbonyl group by resonance, by transferring its pi electron towards the carbonyl group. Okay, so this is the reason why aromatic aldehydes do not reduce Fehling solution. And look at the mechanism of Fehling solution, how it is oxidizing carboxylate group. The aldehyde is reacting with three molecules of hydroxide. It is producing two molecules of water and one molecule of carboxylate group along with two electrons. Okay. So copper 2 positive is reduced to copper 1 positive by gaining two electron. So here cupric ion gets reduced to form copper positive. Reduction. After reduction, this will react again with two molecule of hydroxide ion. And upon reaction with two molecule of hydroxide ion, it will form cuprous oxide. Clear? So, which is these precipitates are red in color. 1 second, I would like to connect my laptop with charger. Okay, yeah. So the electron released from here reduced copper 2 positive to copper 1. Here the oxidation state of copper is 1, and in this the copper 2 have the oxidation state of 2. Clear? So the second step is reduction. First step is attack by OH negative ions upon this carbonyl group so that it can be reduced to carboxylate ion. That second step is the reduction of Cu2 positive into Cu1 positive. And again, the third step is the reaction of this copper positive and OH negative. So upon formation of these precipitates, um, it gives the positive test. So the formation of precipitates is possible only in the case of basic medium. So in Fehling solution is highly basic in nature. So this is a major difference between tolerant reagent and Fehling solution. So in summary, we can concluded that aldehyde give both tolerance reagent test and Fehling solution test. Yeah. Okay. But ketone do not give. Only ketone. Which ketone? Only fructose. It can give both. Tolerant reagent test. It can give tolerant reagent test. Clear? Okay. Then aldehyde, which is saturated. It give only tolerant reagent test as well as fehling to solution test. Okay. But the aromatic aldehyde, it only give tolerant reagent test positive. So this is in the summary. Saturated are oxidized by both reagents. Only aromatic aldehyde is oxidized by only tollens reagent, and the fructose is also reduced by tollens reagent. This is only the ketone. So clear? So this is the way we can distinguish aldehydes from ketone because these two are mild oxidizing agents. Yeah. So please, if you guys like my video, please share and subscribe my channel for the more videos, and you can also ask the questions and pin me in the comment section if you have any kind of query. Thank you.